much more effectively.
Okay. And they do this through the concept of attention.
Right.
What is attention?
Attention is a mechanism that allows the model to focus on specific parts of the input sequence that are most relevant for the current prediction.
So it's kind of like the model is reading the text with a highlighter and picking out the key words and phrases.
Right.
Okay. And transformers use a special type of attention called self-attention.
Yes.
What is that?
Self-attention allows the model to attend to different parts of the same input sequence, so it can capture relationships between words and within a sentence.
So it's like the model is having an internal dialogue with itself.
Right.
Okay, so self-attention is a key part of what makes transformers so powerful.
Exactly.
And this chapter introduces specific transformer-based models, like BERT and GPT.
Right.
Can you tell us a little bit about those models?
Sure. BERT stands for Bidirectional Encoder Representations from Transformers. And it's a very powerful language model that's been pre-trained on a massive text data set.
Okay, so it's kind of like BERT has already read a ton of text.
Right.
And it's learned a lot about language.
Exactly.
And then we can fine-tune it for specific tasks.
Right.
Okay, what about GPT?
GPT stands for Generative Pre-trained Transformer, and it's specifically designed for text generation. It's been trained on a massive data set of text, and it can generate incredibly coherent and human-like text.
GPT is the one that's behind those AI writing assistants that can write like entire articles and poems.
Right.
And even code.
Exactly.
That's pretty amazing.
It is.
Okay, so we've got BERT, we've got GPT. What else is there?
There are also more advanced versions of GPT, like GPT-2 and GPT-3, which are even more powerful.
Okay, so the technology is constantly evolving.
Right.
It's incredible to think about how good AI is getting at generating human-like text.
Yeah, it's pretty amazing.
Okay, so we've explored image generation, style transfer, deepfakes, text generation. What else can generative AI do?
Well, it can also compose music.
Really?
Yeah.
I haven't thought about that.
Chapter 11, Composing Music with Generative Models.
Yeah.
Dives into that world.
So how do we even represent music in a way that AI can understand?
That's one of the challenges. Music representation involves capturing both the symbolic information, like notes and chords, and the temporal aspects, like rhythm and tempo.
Okay, so it's like translating the language of music into a language that AI can comprehend.
Exactly.
And this chapter talks about different approaches for representing music data, like symbolic representations using MIDI and audio-based representation.
Right.
Okay. And once we have a way to represent music, what kind of models can we use to generate it?
This chapter explores different models, including attention-based LSTM models and a model called CRNGAN.
CRNGAN.
Yeah. What is that?
It's a model that combines the power of LSTMs with JANs to generate music.
Okay, so we're using JANs again.
Right. JANs are very versatile.
And this chapter also mentions a model called MuseGAN.
Yes.
What is that?
MuseGAN is a more advanced model that can generate polyphonic music.
Yeah.
Meaning music with multiple independent melodic lines played simultaneously.
So it's like composing an entire orchestra using AI.
Right.
Wow, that's pretty incredible.
Yeah, it's pretty amazing.
Yeah.
Okay, so we've covered image generation, dotted style transfer, deepfakes, dot text generation, music generation. Is there anything else that generative AI can do?
Oh, well, it can also play video games.
Really?
Yeah.
That's awesome.
Chapter 12. Play video games with generative AI. Genial. It's all about that.
Okay, so how does that work?
This chapter explores how generative AI and reinforcement learning can be used to train AI agents to play video games.
Okay, I know a little bit about reinforcement learning.
Right.
It's basically the idea of an agent interacting with an environment and learning through trial and error.
Exactly.
But where does generative AI come into play?
One of the challenges in reinforcement learning is figuring out what the rewards should be.
Okay.
So what actions should be rewarded and how much. And that's where generative AI can help.
So generative AI can help design the reward system.
Right.
Okay, and this chapter introduces a technique called inverse reinforcement learning.
Oh, IRL.
What is that?
IRL is a way to infer the reward function from expert demonstrations.
So it's like watching a pro gamer play and trying to figure out what they're doing to achieve those high scores.
Right.
And then we can use that knowledge to train our AI agent.
Exactly.
Okay, and to implement IRL.
Right.
We use something called JL.
Right.
What is JL?
JL stands for Generative Adversarial Imitation Learning.
Another one of those AI acronyms.
Right.
So how does GL work?
GL uses GANs to train a policy to mimic expert behavior.
So it's like the AI agent is learning by watching
Yeah,
and imitating the pro.
exactly.
Wow, that's pretty cool.
Yeah, it's a very powerful technique.
Okay, so we've explored a lot of different applications of generative AI, but I'm sure there's even more out there. What are some of the emerging applications that are pushing the boundaries of this technology?
That's a great question. And that's the focus of Chapter 13, Emerging Applications in Generative AI.
Okay.
This chapter looks beyond the traditional applications that we've discussed and explores how generative AI is being used to solve real-world problems.
Okay, like what?
For example, generative AI is being used in drug discovery, protein structure prediction, and even solving partial differential equations.
Well, those sound like some pretty serious applications.
They are.
Okay, so generative AI is not just about creating cool images and music and video game bots.
Right.
It's also being used to advance science and engineering.
Exactly.
Okay, I'm really interested to learn more about these emerging applications. All right, let's jump into those emerging applications. Chapter 13, Emerging Applications in Generative AI. You mentioned drug discovery. How is generative AI being used in that field?
So drug discovery is all about finding new molecules that can interact with specific targets in the body to treat diseases. And generative AI can be used to generate novel molecules with desired properties.
So instead of like traditional methods, where you might have to test thousands of molecules to find one that works, you can use AI to kind of design new drugs from scratch.
Right. It's like having an AI chemist that can explore a vast chemical space and come up with new molecular structures that might have therapeutic potential.
Wow, that's incredible. But how do we know if these AI-generated molecules are actually going to work?
Well, that's where the expertise of chemists and biologists comes in. Generative AI can generate candidate molecules, but these candidates still need to be tested and validated through experiments to confirm their safety and efficacy.
So it's like AI is giving us a head start, but it's still a collaborative effort.
Exactly.
Okay. You also mentioned protein structure prediction. How is generative AI being used in that area?
So proteins are essential molecules that perform a wide variety of functions in living organisms.
Yeah.
And the 3D structure of a protein determines its function.
Right. So if we can predict the structure of a protein, we can better understand how it works.
Exactly. And generative AI can be used to predict protein structures by learning from large data sets of protein data.
So it's like teaching AI the rules of protein folding.
Right. And one of the most groundbreaking developments in this area is AlphaFold, which is an AI system that has achieved remarkable accuracy in predicting protein structures.
I've heard of AlphaFold.
It's a really impressive system.
Okay. And then the last application you mentioned was solving partial differential equations.
Right.
PDEs.
PDEs are mathematical equations that describe how things change over time and space. And they're used to model a wide range of phenomena in physics, engineering, finance, and other fields.
Okay. So they're pretty important.
They are.
But they can also be very difficult to solve.
Exactly. And generative AI can be used to approximate solutions to PDEs.
So it's like teaching AI to understand the physics of a system.
Right.
And then using that knowledge to predict how the system will evolve over time.
Exactly.
This is incredible, it seems like. Generative AI has the potential to revolutionize so many different fields.
It does. And these are just a few examples
Right.
of the emerging applications. I think we're just scratching the surface of what's possible.
This has been an amazing deep dive. I've learned so much about generative AI. Thank you so much for sharing your expertise.
It's been my pleasure.
So to wrap up, what final thoughts would you like to leave our listeners with?
Well, I think the most important thing to remember is that generative AI is a powerful tool. It has the potential to do a lot of good in the world, but we need to use it responsibly. We need to think about the ethical implications of this technology and make sure that it's used for the benefit of humanity.
Well said. I think that's a great note to end on. So thank you again for joining me on this deep dive into the world of generative AI.
Thanks for having me.
And to our listeners, keep exploring, keep learning,
Yeah.
and keep pushing the boundaries of what's possible